folks, and welcome to 4.2 Graphing Parabolas in Vertex and Intercept form. So today we're going to talk about graphing in two different forms, whereas yesterday we graphed in standard form. Okay, another word for intercept form is also called factored form. So these two words mean the exact same thing. So we're going to go ahead and review what we did yesterday and maybe make a connection between what we've done in the past and graphing in these two forms. So first and foremost, let's just review standard form. So what I did is we started with the form in standard form, ax squared plus bx plus c. Sorry, that was pretty bad x there. So ax squared plus bx plus c, that is standard form. Okay, and what we used is this formula, negative b over 2a. And what we did is we found our x value that correlated with that negative b over 2a, which was our vertex, the start of our vertex. We found that point. We found 2 points on either side. We plugged them in and we found our y values. Okay, now what if I asked you these two questions? What does this function look like in factored form? Again, remember another word for factored form is intercept form. Okay. And what are the x-intercepts of this graph? So if I were to ask you these two questions, would you be able to using the function that we've given? So what I would do is I would take the function and I would factor it. So let's use the AC method. 1 times negative 8 is negative 8. 2 factors of negative 8 that make negative 2 would be negative 4 and positive 2. Make your table. And if you weren't sure, you do not need to write this down. We're just reviewing some stuff, and I just want to make sure that you're paying attention. So then I do x squared minus 4x positive 2x minus 8. What do they have in common in this row? X, this column, and this row. And so the factored form of this problem would be x minus 4 and x plus 2. That would be the y equals those factors. That would be what intercept or factored form look like. Now, how would I find their x-intercepts? Well, this is the tie-in, okay? Factoring and finding the intercept is the tie-in for solving. Remember when we factored to solve. When you factor to solve, you take your factors, you set them equal to 0, and you find your x value. When you do that, you are finding the intercepts. So in this graph, the intercepts are negative 2 and 4. And if I just had my vertex, 1, negative 9, all I would need are those 3 points to make a nice parabola. So I don't need 5 points to graph a parabola. And in intercept form, I'm already given 2 points. So when you are given the graph in factored form is what we're going to do right now. How do I graph a parabola in intercept form? Or again, that's factored form. Okay, that's what it means. If I were to graph a parabola in intercept or factored form, I am going to look for my 2 x-intercepts, and then I'm going to find my vertex. So you really only need 3 points when you do this. So you're going to make a very small table. And you do need to write this down, so make sure that you are writing this down, okay? So now let's go ahead and figure out how we would do that. So let's graph an example in intercept form. So here's my graph in intercept form. The first thing I'm going to do, intercept or factored, means the same thing. I'm going to keep reiterating myself on that because I want to make sure that you know that factored form and intercept form mean the same thing. what you're going to do is you are going to find your x-intercepts by solving each factor set equal to 0. So if I take my first factor and set it equal to 0, I get x equals negative 3. If I take my second factor and set it equal to 0, x will be 1. The two values that I'm going to use are 1 and negative 3. Now what's really cool about that is that when you plug an x in to 1 plus 3, which is 4, times 1 minus 1, which is 0, anything times 0 is 0. The x-intercepts, the y is always 0. So if I plug negative 3 in, I would get 0 times negative 3 minus 1 would be negative 4, and anything times 0 is 0. So that's a quick 2 points right there for you. 1, 0, and negative 3, 0. Now, all I need is the vertex. Now you're probably thinking, well, how do I get the vertex? Because it's not in standard form, I cannot use negative b over 2a. I can't use that. So how do I find the vertex? Well, this is really cool. Find the distance between these 2 points and divide it by 2. Because the vertex is always going to be in the middle of every 2 points you have, because it has symmetry. So if I figure out that there are 1, 2, 3, 4 units between these two, half of 4 is 2, and so our axis of symmetry, right, is x equals negative 1. My vertex is going to be negative 1 something. Now we don't know what that something is, so we need to figure it out by plugging it in to the formula. So the equation here, negative 1 plus 3 times negative 1 minus 1. Negative 1 plus 3 is 2, times negative 1 minus 1 is negative 2. Negative 2 times 2 is negative 4. There's my vertex right there. Okay, now that I have those 3 points, I can make a nice U-shaped, make sure it looks like a U and not a V, okay? And I can go ahead and answer all these questions. Do I have a maximum or a min? Well, I have a minimum value, and that value is negative 4. My domain is x such that x equals all reals. My range is y such that y is greater than or equal to negative 4. And now my increasing and decreasing intervals. Remember what I told you in class yesterday, that if you put negative infinity over here and positive infinity over here, from negative infinity all the way to this, what is the graph doing? Remember, we'd have to walk down, so this is decreasing. So the decreasing interval is from, oops, sorry, my decreasing interval is from, oh, I don't know why my thing keeps doing that, negative infinity to negative 1. And my increasing interval is from negative 1, because this is increasing because I have to walk up it, is from negative 1 to positive infinity. Okay? That's how you graph an intercept form. Another form, vertex form. Vertex form has to do with the shifting. Remember shifting in absolute values. So we talked about how things would shift. What's inside the absolute value would make it shift left or right. What was outside of the absolute value made it shift up or down. Okay? So the vertex on this equation that I have in front of me would be no shift left or right, and 2 up or down. Okay? This one would be no shift left or right, but down 4. This vertex would be, ooh, I have a shift. It's going to be right 5, because remember it's opposite when it's inside the absolute values. So right 5, and it doesn't shift up or down, so it's 5, 0. This one would be negative 5, opposite of positive is negative 5, and it doesn't shift up or down, so it would be negative 5, 0. This one doesn't have a left shift or a right shift or an up shift or a down shift, so the vertex would stay 0, 0. Now the same thing happens when I have parabolas. So if I have these parabolas, this says nothing is affecting my x squared, but I am moving up 2. This says nothing is affecting the left or right, but I'm going to go down 2. Uh-oh. Now this one says, kind of looks like this one over here, and so if this was a right shift on the absolute value, guess what this one is? It's also a right shift. So it's 5, 0. This one would be negative 5, 0. This one doesn't have a left or right shift or an up or down shift, so it would be 0, 0. Okay. So having that in mind and that shifting means that then if we know the vertex right away, we again do not need to use the formula opposite of b over 2a, and we can just go straight to our table and make a table. So let's graph in vertex form. By looking at this graph, y equals 1/2 x minus 3 squared minus 5, what is the vertex? The vertex is, let's look at the shifting, right 3 and down 5. So the vertex goes in the middle of your graph, right 3, down 5, boom, you have a vertex. 3, negative 5. Now all you need to do is figure out what two values you're going to use on either side of 3. So 4, 5, 2, 1, and plug them in. Half of 5 minus 3 squared minus 5. 5 minus 3, 2. 2 squared, 4. Half of 4, 2. 2 minus 5 is negative 3. 1/2 of 4 minus 3 squared minus 5. 4 minus 3, we're following order of operations, folks, or we're using our calculator. 4 minus 3 is 1. 1 squared is 1. 1 times a half is a half. A half minus 5 is negative 4.5, or 4.5. Negative 4.5. You can use decimals if you'd like. Then let's do 2. 2 minus 3 is negative 1. Negative 1 squared is 1. Half of 1 is a half. Half minus 5 is negative 4.5. Let's do the same thing for the last one. Negative 2 squared is 4. 4 times a half is 2. 2 minus 5 is negative 3. And then I can go ahead and graph this over here. 3, negative 5 is my first point. 4 and 4.5, negative 4.5. 5 and negative 3. 1 and negative 3. Draw my U shape. Hopefully your U shapes are better. Okay, axis of symmetry. Always draw that in. X equals 3. You've got to have that x equals. Is it a minimum or a maximum value? It is a minimum value. It is a minimum value of negative 5. Okay. Domain, x such that x equals all reals. Range, y such that y is greater than or equal to negative 5. Increasing intervals, again, we want to make sure that we're talking about our x values here. So what's happening from negative infinity all the way to the x-axis? What is happening? This graph is decreasing, so my decreasing interval is negative infinity to 3. And then from 3 to positive infinity, what's this graph doing? It's increasing. So it's increasing from 3 to positive infinity. Okay, so that's how we use vertex form. Vertex form gets us the vertex right away. Okay, intercept form gets us the x values right away. Now, if you would rather graph using standard form, you could. All you'd have to do is get your equations in standard form. So how do we get our equations in standard form? Well, if I were going to do this one in standard form, the first thing I would do is double distribute. X times x is x squared. X times 6 is 6x. Negative 4 times x is negative 4x. And negative 4 times 6 is negative 24. Then I would multiply, bring this multiplication of 3 down, and distribute. So I would get 3x squared plus 18x minus 12x minus 72. And I would add like terms. So y equals 3x squared plus 6x minus 72. And then I could use opposite of b over 2a if I wanted to. So this form right here that I'm looking at right now is factored form or intercept form. If I multiply it through and get my formula, I should be able to get my formula in standard form. Now this is in standard form, and to graph in standard form, I need the opposite of b over 2a. Okay? Well, okay, let's take a look at the other form we talked about today. The other form that we talked about today was this form, which is vertex form. Now, if I don't like vertex form, what I can do is I can put it in standard form again. So this time what I need to do is I need to say, what does x minus 4 quantity squared mean? This means x minus 4 times itself. Okay. So what I do again is I would double distribute first. X times x is x squared minus 4x plus 16. Bring down the plus 1. But before I added the plus 1, I will multiply by my negative 1 through. And I can do that because this is to a power of 1. So I can use the distributive property here because this is to the power of 1. So negative x squared plus 4x minus 16 plus 1. And so my equation in standard form would be negative x squared plus 8x minus 15. That is standard form. Now if I wanted to again, that's how I would graph it. I'd use the opposite of b over 2a. So if you don't like graphing in your factored intercept forms or your vertex forms, you most certainly can get them in standard form by multiplying them through. Okay, that's it. We'll see you tomorrow.